All right, we are adding rational expressions today. And once again, we are going to drill it into your heads that rational expressions are fractions. And today we're adding fractions. We're also going to be subtracting fractions. And we must have common denominators when we add or subtract fractions because we're talking about combining like terms. So if we look at the first one, we have this lovely fraction here. We have x squared minus 4x plus 3 minus x over x squared plus 2x minus 3. And since we are adding, the first thing we have to do is inspect the denominator because this signals our brain that we must have common denominators. It's not like multiplication or division where you can just multiply anything you want together. And when we look at these, we see they are not alike. We see squareds, and we know we have to factor to get a closer look at what we have there. Okay, so I'm going to factor, and this is what I get when I factor. We must make the denominators the same. So what we have in here is I kind of call it the big soup. Wow, don't know where that came from. Okay, so we have x minus 3, x minus 1. Here we have x minus 1, x plus 3. So we're happy with one thing. We know that we both have x minus 1s. That's great. So how are we going to get the other ones the same? Well, we're just going to multiply. See how this has an x minus 3? And this one doesn't have an x minus 3? Well, we're just going to take that x minus 3 from the other one, and we're going to multiply top and bottom by x minus 3. So now this one has an x minus 3 and x minus 1. This has an x minus 3 and x minus 1, but it doesn't have the x plus 3. So now I'm going to take and multiply this top one by x plus 3. So there, we have a common denominator. Both of them have x plus 3, both of them have x minus 3, and both of them have x minus 1. Sometimes this is called making soup. You know, you just take everything in the house, throw it in the soup, and hopefully it works out. Okay, now that we have this here, we have to multiply the numerators out. So up top I have x squared plus 3x. And on the bottom I have my x plus 3, I have my x minus 3, I have my x minus 1. Okay, over here I have my x squared minus 3x. And on the bottom I have my x minus 1, x plus 3, and x minus 3. Now you may be asking, how come I'm not multiplying the denominators out? And you'll see why in a minute. The next thing I want to take care of is the subtraction. I am subtracting all of this. So to make that, I don't know why that's coming up, sorry. So to make this work, we know that we're going to take the subtraction and we're going to distribute it. So that becomes minus x squared and a plus 3x. So now when I combine everything, x squared and a minus x squared cancel out. A positive 3x and a positive 3x give me 6x. And I'm left on the bottom, x plus 3, x minus 3, x minus 1. And here's the reason why we didn't multiply out this bottom. We would have to reduce our fraction at this time, but there's no reduction going on here. I have a monomial up top and I have binomials on the bottom, and we know that monomials and binomials cannot reduce with each other, so this is our lovely fraction. And if we were doing a little pre-calculus, just to throw it in there, x could not be a negative 3 because that would give me 0, a positive 3 because that would make 0, or a positive 1. You don't need to know that, but I always like to throw it in. Okay, example 2. All right, so remember our steps. All right, we need a common denominator. So I'm going to factor so I can look at my denominators a little closer. Okay, so there's my factorization. Now I need to make my factors the same in the denominators. So I'm going to make my soup. And I'm going to look here. Well, this guy right here has an n and an m minus n. All right. This guy has an m minus n. Well, what does he need from the other guy? He needs an n. And so what we ever do to the bottom, we've got to do to the top. So now I have at least the first fraction and the second fraction looking the same. So now let's look at that third fraction. What does that third fraction need? It needs an m minus n. So we'll give this one an m minus n. And if I look now, I have, I'll just put these in parentheses so they're offset, common denominators. So now we go to the numerators and we multiply the numerators together so that we can start getting ourselves one giant fraction. I have m minus n times 1 is n minus, and then in parentheses, m minus n. And at this point, as soon as I see this minus, I'm going to distribute it. So I'm going to actually take this back, and I'm going to distribute that minus, so I don't have anything to worry about. Distribute it to this, distribute it to that. So I get minus m, and I get plus n. And that's all over n, m minus n, because they're common denominators. Hey, I like this one. Look what happened here. M minus m cancel out. Negative n and positive n cancel out. And I'm left with 0 over n m minus n, which really is the fraction or the number 0. Yeah, that one wasn't that bad. Okay, here we go again. Question 3. There's only 4, so hang in there. Last one's pretty easy. We're going to look at the denominator. We know they have to be like because I'm adding fractions together. We're going to factor to get a closer look, but I got a problem going on here. All right, there is no factoring going on, but man, they look alike. This is an x minus 4, and this is a 4 minus x. They have to be the same in order for me to add them together. Well, I can do a little manipulation here. I've got my choice. Right? If I take x minus 4 and I multiply it by a negative 1, I get negative x plus 4. And if I rewrite that, I get x. I get 4 minus x. If I change, and that is the same as that. Or I could take 4 minus x, multiply it by a negative 1, and get negative 4 plus x, which if I rewrite that is x minus 4, which is the same as that one. So I've got my choice. I can multiply either one of those by a negative 1. And I don't know why, but I like my x's to always lead the way. I don't know why. I hate having a number lead the way. There's absolutely nothing mathematically wrong with that. It's just a matter of opinion. So I'm going to take this first fraction right here and multiply top and bottom by a negative 1. Negative 2 plus 3 over, and we know that this 4 minus x multiplied by -1 turns into an x minus 4. So the common denominator is x minus 4. And if I add those together, there is my final answer. And if we're doing a little pre-calculus, we know this fraction is undefined when x equals 4. So x cannot equal a 4 in this case. Okay, so last example. Last example is pretty easy. I want to take w minus and minus 2 over 5w from it. So I need, again, a common denominator. And I know you love to do this. You love to put it over 1. So if I put it over 1, this has a denominator of 5w. This has a denominator of 1. So obviously this one over here has to be multiplied by 5w to make it common. Next thing I'm going to do is multiply out the numerator. So I get 5w squared minus 2 over 5w. I look to factor, see if I can do any canceling, but nothing cancels here because nothing factors. This is a binomial. This is a monomial. You cannot cancel like that. Please learn you cannot cancel like that. So this is my final answer. All right, now there was another way to do this, which I'll show you real quickly because you may like it better. Let's say I gave you 2 2/3 and I asked you to change that into an improper fraction, which there is no such thing. If I asked you to change it from a mixed number to a fraction, you would do 2 times 3 is 6 and then add the 2. So it would be 8/3. Well, I can do the same thing right here. I'll multiply these to get 5w squared, and then I have a minus 2 over 5w. Because this is really a mixed number. Little shortcuts. Okay, we're done.